Okay, so we now at our last tutorial for business intelligence system, and in this tutorial we're going to be able to use a business intelligence software. So as we already explained from the previous tutorial, where we looked at the main stages of business intelligence, where we have several databases with raw data, which are now passed into our data warehouse, where it simply collect all this raw data, and it now completes ETL, where we evaluate and transform the data. Once in our warehouse, our data warehouse, the data has been cleaned and modeled, we can now pass into our business developers, our business users. So looking into modeling tools, there are several tools to complete this task, such as Oracle SQL Developer Data Modeler, or even Power Designer, where these softwares, such as Oracle, they can now complete some modeling, some design, where our data architecture will now create some nice some nice graphical representation, and can now create some really useful model, which will be used from our developers to improve the insights. So also we need to look into search criteria, where we need to be able to define and write down the questions, identify and keep a record of keywords, identify keywords synonymous, and determine a time frame from the research. So when it comes to bespoke business reports, learners should include a bespoke business report which use a data set. The data set should include a range of data from within the report in order to provide sufficient analysis. Also, for our indicative content, we are going to look into dashboards, which are used by our developers, where learners should develop a dashboard to display business data visualization. The dashboard should include a range of visualization, such as a pie chart and a bar chart visualization, and use of underlining data set to provide the live real-time data functionality. Also prepare unclean data, where we're going to use retention period, backup, deletion, and data classification. So these are couples of indicative content, where we will now complete the process, where we collect raw data from our database, our Oracle databases. By collecting the database, we will now use our data warehouse to retrieve them and execute OLAP or ETL. And once this is done, we can now pass them into the dashboard, where we can complete some data visualization, data analysis, which we did a tutorial. We had a tutorial where we learned how to do some data analysis with Jupyter Notebook, and we visualized some chart. We simply imported our CSV file and we just did some visualization. So from our indicative content, we now have to do the same thing with a dashboard. And this dashboard has to do some visualization as a pie chart, which we did not plot the pie chart in our tutorial, but all this information can be found on sklearn or even Cargo website. And then moving forward, for today's session, we are going to use modeling tools to document intelligence data, develop search criteria for reviewing data, create a bespoke business report from datasets, develop dashboard to display business data visualization, and prepare and clean data from business intelligence system. So now we can have some example of tools which are used for business intelligence. We already introduced some of them in our other tutorials where we spoke about IBM Cognos and many other softwares. So in today, we're going to look at two examples, which is SAP Power Design, which will allow us to do some modeling. It is a modeling tool which produced by BICES. With SAP Power Design, it has its own application, but it also can be run on Eclipse environment just by adding some plugins. So here there's a YouTube video where there is a developer which is creating some simple data architecture where he recreates some design, some diagrams with this software. So we might have a quick look into it. Let me just
of SAP Power Designer for data architects. My name is George McGeeky. You can find me on Twitter and on WordPress as Metadata Junkie, and I supply consultancy and training in Power Designer. What we're going to do in this demonstration, which comprises of 4 sessions, is create a conceptual data model in Varka notation. From that, generate and edit a logical data model in a different notation. Then generate and edit a physical data model after doing some more changes to the LDM. We're going to generate SQL for the database, quickly show you the capabilities of Power Designer for building an OLAP cube of facts and dimensions from your tables. Then in the final session, I'm going to create a project to show the links between the models and demonstrate the traceability that Power Designer supplies. What I'm going to do first is create a conceptual data model. Now in Power Designer, conceptual data model is something that can look a lot like a logical data model with a couple of differences. One difference is that no attributes are migrated at all. And the other difference is that every attribute has an underlying data item, and data items can exist by themselves. In my model options here, I'm making sure that my notation is set to Barker, and you can see some other choices. And I'm going to leave these other settings here as well. As this is only a short demonstration, I shan't be saying very much more about data items. But I'm sure I will mention that in a future presentation. So now I'm going to create a number of entities. I'm going to create the first one by drawing from the toolbox over here, and I'm going to call this one when I learn to type, I'm going to call it loyalty account. And I've just put the name in the clipboard there. Right-click the mouse so I stop drawing. What I want to do now is show you a quicker way of creating a number of entities. I create a list of entities, and you can see here that it's quite easy for me to create more entities. I could carry on drawing them, but I chose to do it this way. If I had a spreadsheet with these entity names in, I could quite easily import them. Right, that's fixed all my typing errors there. There are all the entities I've just created. So now I'm going to do the sensible thing and save my new model because it doesn't exist as a file yet. And I'm going to save it into this folder I've called 15-minute demo. So there it is saved. Now I need to restructure these slightly because two of my entities are actually subtypes of loyalty account event. So because there's Barker notation, the way we handle subtypes is we actually have them embedded inside. It's box in box, a bit like a Venn diagram. So here we have loyalty account event, loyalty account status, and loyalty account. Now I'm going to add some attributes. So loyalty account status, I'm going to add an attribute to here, which will be loyalty account status code. I'm going to say that it is part of the primary identifier for it. I'm going to add a description attribute, which is mandatory. I will deal with the data types shortly. So here we have loyalty account status and its two attributes. Loyalty account will have an attribute of point balance, which will be mandatory. Loyalty account event has something similar, but it's an initial point balance. Again, mandatory. The purchase doesn't have any special attributes of its own, but the transfer has a point count for the number of points we're transferring. So there we have all our attributes. I'm going to have a quick look at the display preferences here for entities. After I've checked the word wrapping, it's not word wrapping at the moment. I need to change my defaults. I'm going to make it automatically word wrap at 40 characters, which means I can now if I make the entities narrow enough, the entity names word wrap, but I'm afraid the attribute names do not. So if I just press Control J, it makes it the right width for the text. The other thing I'm going to look at in the display preferences is for entities. I am showing here all the attributes, and I'm going to show a property which is either the domain if there is one, or the data type if there isn't one. These all say undefined in these attributes because they have neither a domain nor a data type. Now, when I draw a relationship here, I can choose between different kinds of relationships. I'm going to draw, first of all, a many-to-many relationship, which I am going to call loyalty account status. Correction, a loyalty account state for reasons that will become obvious later on. And I'll be tidy and just tidy those up. Now I'm going to create a relationship a dependent relationship from loyalty account to loyalty account event. Now, in a logical data model, as a result of this relationship, foreign key attributes might migrate. But in this model, they will not. As we'll see here, loyalty account number, I'm adding this attribute here, and I'm just going to move it to the top because I want it to be the primary identifying attribute. So now this entity loyalty account has an identifying attribute, but it's not migrated across to loyalty account event as a foreign key because this is a CDM. I have one more relationship to add, which is another one from loyalty account to loyalty point transfer, representing the target account in a transfer. This is not a dependent relationship. I'm going to draw it this way. I think I'll change my preferences for relationship lines as well. Modify them so they look like that. Right angles and nice rounded corners. Here we go. For my next trick, I'm going to open this model here, which has standard conceptual data model domains. And I'm actually going to just drag them onto my new model, hold down the control key so they get copied. Now I can close my domains model. You can see now I have a series of domains here that I can use. I will need to add one or two more. Now, to attach those two attributes, I could go to an individual attribute and choose the domain from the list here. So I attach it to the description attribute that has a data type of text. So you can see the word description, the domain name appearing on the diagram now. But a quicker way can be to create a dependency matrix. In the rows, I will place the data item, because data items you can see on the browser exist, they underpin all the attributes. The domain is a kind of object I want to attach to the data item, and the property called domain is the link between the two. We can see here I have a number of data items in the rows, and in the columns I can see I have some domains, and you can see here the domain I've already linked. What I haven't got at the moment is another domain for things like initial point balance. So what I'm going to do is create a new one, which I will just call points, and its data type I will say is number 8. We're very generous with points. So the new domain has appeared over here, and I'm going to very simply press the space bar to link that domain to 3 attributes. My loyalty account number, for now, I'm going to say it's an identifier. Loyalty account status code doesn't have a corresponding domain. In fact, I can see if I click on here, this is the only data item that doesn't have a domain as yet. I actually want it to have a domain of the same name. So I've copied the name here, click on the button here to create a new domain called loyalty account status code, and I'm going to make this one 2 digits, 2-digit number. There we are. So I have now finished my conceptual data model. Every single attribute and its underlying data item now has a domain. I'm going to save for now. I very briefly show you the model check capabilities. Power Designer comes with quite a large number of things you can check. The cross and the red circle, if an entity name is not unique, in this case that would cause an error, be reported as an error. The entity name being too long would just be reported as a warning. Now that's important when you generate models, because if you're doing a model check when you're trying to generate a model and you find some errors, the model generation stops, so you have to fix them. You can add your own areas, your own model checks if you like. Here I've not attached any model extensions that include them, so these are all standard ones. Now if I run this model check here, you can see I've got one error, is that I have an entity that doesn't have any attributes. That's one of my subtypes. The same entity doesn't have an identifier, and it also doesn't have any relationships. So that's what's wrong with this model at the moment. As far as the model check is concerned, it's up to me to decide how critical those errors are. So here's my CDM. I've finished with it for now, so I'm going to close it. And it just remains for me to say thank you for watching, and please join me for the second video in which we create a logical data model. Thank you.
So the video was a demonstration of Power BI, our design, where he implemented some modeling into the program. I do know another type of program which will allow us to create some representations, which are So with this app, why is it not working? 1 second. So I do believe that draw.io allows us to create. I'm going to check the spelling.
Can you try right-clicking and opening with as admin?
Yeah.
Yeah.
So I use the other day. No, I have to uninstall it and reinstall it again.
Okay.
Yeah. Anyway, what I was trying to show is that this app allows us to do some modeling as well, instead of using Power Design. We could use draw.io, which allows us to create entity relation ERD diagram, entity relationship diagrams, such as the way the guy on the video was creating it. So Draw.io is a free open source, which can be downloaded and run. And we can now make some modeling, which will be useful for our business intelligence system, where the process from the design will be more simple and understandable for the business purpose. So other key features of Power Design is so there are information mapping, where documents dependency accurately with a drag and drop mapping editor. So for example, we saw from the video, the guy was able to drag and drop items, while maybe with the Draw.io, we have to type them manually. We have to insert them manually, because it's not as dynamic as much as Power Design. Also, the benefits document generation, where you can provide secure controlled access to metadata through the wizard-driven list, where there are multiple model documents and hyperlink to web reporting. And the other impact is there are impact analysis, where it integrates all the module type by using automatic linked and sync technology, and streamline communication and collaboration to increase organization responsiveness. So, other benefits of using these modeling tools is that they will align with the business IT, where we can now improve the data, the way our IT are working within the company. You also improve the team productivity, as we can see, where everyone is now trained and can work with these excellent data architecture tools. Then there are other benefits such as document, we now enhance our existing system, where the IT staff will be more flexible by using these tools and having more functionality for creating the reports. So when it comes to Oracle SQL Developer Data Modeler, also this we can see is a free graphical tool, which has pretty much the same benefits of Power Design. So using Oracle SQL Developer Data Modeler, users can now create, browse, and edit logical, relational, physical, multidimensional, and data type models. So by using this, we can now do more data manipulation, where the tool will allow developers to do all this nice modeling. So there are a couple of videos here which we can watch about how Oracle SQL Developer Data Modeler works.
Oracle SQL Developer Data Modeler version 4.0 has several diagram navigational aids to help you work with your designs more easily. If you're looking at a blank canvas in your diagram, there are several ways that you can easily get to what you're looking for. You can begin by right-clicking on a table, say Go to Diagram, and this will automatically navigate you to what you've clicked on. So this table is active from where I searched for it using the tree. You can also use the navigator. The navigator allows you to see the entire diagram on a single pane and to easily go from one part of the model or diagram to another. You can also zoom in and out of your diagrams until you can see everything you need in context.
Yeah, as we can see, pretty much have
So get this, every 1 point
to create ERD diagrams, which was pretty much the scope of Power BI, Power Designer. Coming back to our presentation. Going back to our presentation, now we're going to look into following steps, such as develop search criteria for reviewing data, create a bespoke business report from datasets, develop dashboard to display business data visualization. So, as we already mentioned, the purpose for this business intelligence system, we will now to be demonstrate search criteria, preparing business bespoke report involving datasets, developing dashboard to display business data visualization. So we do have nice videos here, which will cover each of them. So let's just look at the length.
Hello, welcome to this short demonstration of SAP Power Designer.
No, I think it's still the same video.
Hello, welcome back to this short demonstration of SAP Power Designer for data architects. This is the second session. In the first session, we created a conceptual data model in Barker notation. Now we're going to generate and edit a lot.
Okay, from these videos, I can see that the guy is walking us through all these steps. The videos are quite long, so I'm not going to spend much of our time on them. Maybe the only one that might be more focused on is looking into the dashboard and some data visualization. So let's see if there's one of these videos.
The crazy loophole where you just do 4 hours of work and it generates a new income stream that...
Hello, and for data, we are going to take the logical data model we created in session 2.
Yeah, okay, so in this video is going to generate SQL for the database and use the OLAP, which is using a data warehouse process. So this video might return quite useful for us. It's quite long as well, 14 minutes video. Let's have a quick look at the video.
2, we're going to generate a physical data model representing a SQL Server database. We'll do some editing to that because we no doubt would in the real world. we're going to have a look at the SQL for the database. Then we're going to identify some candidate facts and dimensions for an OLAP cube and build the model of the OLAP cube inside our physical data model. So first of all, let's have a look at the logical data model we have. Remember that we have a number of entities here which were generated from the CDM, and we have loyalty account state. And I have actually added a couple more attributes here to loyalty account state, reason code and effective date time, and we'll be using those in our OLAP cube later on. Let's move on with this then. After a quick look at this inheritance.
We had some problem. I apologize for that, Nikki.
No problem, no problem. Victor, the volume, I think it's not up. I can't hear anything.
Oh, you can't? Sorry.
For generating a physical model from this, but for the sake of demonstration, I will not. And I'm going to save generation dependencies. In terms of selection, I'm going to tell it to run against all the tables, all the entities that I'm allowed to generate from. Here we go. Clicked on OK. On the generation tab here, there are a few messages about from generating the model. It's generated business rules, domains, entities, relationships. It's renamed a couple of relationships. Slightly different rules here about the uniqueness of relationship codes and the PDM. Now looking at the PDM we've created, we see here we've got entity 7. We have loyalty point transfer. loyalty point purchase, and we don't have loyalty point event. The relationships that loyalty point event had in the logical model have been replicated down at the child level here. I'm going to make a notation change here after adding my title symbol here. I'm going to go into display preferences and change the format of references because I don't like these jagged lightning strokes. I'm going to make them right angled with rounded corners because I find on a busy diagram it's easier to tell which line is which if the corners are slightly rounded. Okay, so let me just move that one up there. I'll move this here and this here and this here. Here is our physical data model. I'm now going to look at the generation links viewer. We saw that in the logical model and the generation links. The origin model is the LDM. So we can see the business rule came across, all the domains have come across, and the entities have been converted into tables, and the relationships have been converted into references. At the moment, I haven't saved this physical model yet, so I'm going to save it. Tell it where to put it. It's going in the same folder as the others. Notice the LDM needs saving because it has information there about how it links to the physical data model, so I better save that as well. In fact, now I don't need it anymore. I'll quite happily close it. This is a data model for a data warehouse, and all good data warehouses have source data tables. This one is no different. I have a table here with source data in it. It's going to contain a column just like this one called description text, and it's also going to contain columns called point balance and member name. This one, I'll call that description. This one I will call points. So my source data comes with these three columns. Now I need to tell Power Designer, well, where does this data come from? Let's document that. I'm going to use the mapping editor to do this. I'm going to say that I'm only reading the data and I'm mapping to a physical data model. Click on Next. This is the physical model I want to use as my source, which is the current one. It's the only one open. Do not want to create the default mappings between the source tables and the target tables because they're the same tables. It will map everything to itself. So here we go. Here are my tables. Two views of the same database. Here is the source, and over on the right is the target. So the source data, I'm saying that my source data table is the source for loyalty account. It is mapped one of the columns automatically. Now I'm going to tell it that that one maps to that, and the description, for some reason, holds the loyalty account number. Now, if I look at one of these mappings down here, I can see some information about it. If I select the table on the right, I can see the mapping information for the table, including the SQL necessary to select the data. Nothing's happened to the diagram because that's all behind the scenes. So I'll save the model again. Let's look at the Sql Preview for our source data table. Tables, views, etc., and the model itself have a preview tab showing the code that will be generated. Notice here the code, as you would expect, possibly not in SQL Server, but the code here uses these names which are underscored and in uppercase. Look up here at table properties. We have two names apparently for the table. One is the business name, source data, and the other is that business name converted. In this case, it's just converted to uppercase with underscores. In our conversion rules, we could actually tell it to look up certain words or phrases and abbreviate them. So we could have what might look like quite a different code. If we look at the code here, you see we have the name of the table, and you can see it's automatically generating the code from that name. I will just cancel that to make sure I don't do anything drastic. Have another look at another table, so we can see a more complicated table here. Up here on this toolbar, we can show and amend the options that we use to control how we generate the SQL. What content do we want to have in the SQL? So for table, for example, we can say we do or don't want to create tables, or perhaps we don't want to drop tables. We don't want to drop primary keys. We don't want to drop alternate keys. Down here, once we've finished setting our options, we can save these settings so they can be reused. So that's the SQL required to create a given table. If we look at the properties of the whole model, the model also has a preview tab. This is the SQL that will be generated from the whole model. Realistically, you will probably have users in the model representing schemas, and you'll be generating schemas, but this is an extremely simple model. Again, we can get to the generation options here, and we have a button here that tells it whether or not to actually take any notice of the generation options. So if you click on ignore, this is the absolute maximum that we would generate. So here we're including user-defined data types. Now what I'm going to do is identify potential multi-dimensional objects, potential facts and dimensions. Power Designer has worked out that loyalty account state from this red cube, I can see it's a potential fact and it has some potential dimensions linked to it. Now I'm going to get it to take that information and generate a cube. It will put the cube into this model. Here's the candidate fact. Let's go back. Make it select all those tables as the fact. Here we go. Yes, it's examined all of those. And we have a measure here. I'm going to give it another measure. Click on finish. And it's built me a model here of a cube. If I had the business objects available, I could actually generate a business objects universe from this. Notice it's a slightly different kind of diagram. On the mapping tab here, I can see the criteria, the cube select SQL for populating the cube, all generated from the underlying metadata. I better rename my diagram, my PDM diagram here. It was up here. This tab up here was my PDM diagram, but it was still saying LDM. And now I should save my physical data model. You can see my model has got a few more types of object in it. These associations are here. The facts and dimensions are from the OLAP model. I've got my data source created by the mapping editor and my standard domains, tables and references, and the tables have columns, keys and indexes. Well, thank you for listening to session 3. It's been a very quick walk through these topics. In session 4, we'll glue all this lot together by creating a project to.
So in this video, so the guy in the video just covered the creation of one second. So the guy just covered the creation of a bespoke model where he was using SQL to do some data manipulation, and then as we saw, all the processes done was used for the data warehouse. So now on 4.5, we're going to prepare and clean the data from a business intelligence system. So as we explained in the data warehouse, the main purpose of collecting this raw data from other databases is for it to be processed. So when it comes to process, it has to be clean and integrated before it can be now deployed to the dashboard. So for cleaning the data, we need to have several stages, such as data preparation, which is simply the process of gathering, combining, structuring, and organizing data so it can be used in business intelligence, analytics, and data visualization application. So just from the name, you can clearly understand what is the purpose of having data preparation. So the components of data preparation will include data processing, profiling, cleaning, validation, and transformation. So when we looked into sklearn, we had a couple of examples of processing, fitting, and other type of data visualization, such as also classification. So one of the primary purposes of data preparation is also to ensure that the raw data has been read from the data processing and analyzed into accurate. So the process of the preparation is simply working through all these, working through the data within all these stages from raw to useful data. So as we mentioned, there are a couple of steps for them, such as data collection. We'll just gathering relevant data is now gathered from operational system and data warehouses. So where we have multiple databases, they all now gathered into one single collection. Also, there are data cleansing and data structuring, where in the first step is simply going to identify the data error and which have been collected to create a complete and accurate data sets. Once this is ready to be processed and analyzed. While for data structuring, it's just the process that needs to be structured and organized into a unified format, which will meet the requirement of the planned analytics users. So we're just going to do some data structure for the business purpose. Also, there is transformation and enrichment, where once the data that has been structured will now be transformed to make it more consistent and turned into useful information. While for enrichment and optimization, where there are further enhanced data sets as needed to produce the desired business insight. And at the end, there is data validation and publishing, where it simply focus on the preparation process, automated routine, which are going to be run against the data to validate its consistency. So this is an image which shows the importance of data cleaning, of how important it is to gather, process, and clean and validate our data. So it shows there's 60% of the whole process. And this is a simple image which shows during the year how data preparation has improved the annual revenues of businesses, where we gone up to $3.20 billion, which will be expected to come in the 2023. So this is everything for today's session. Is there any question for me?
No, Victor.
Okay, thank
Just
you for
Thank you.
joining. And tomorrow we will have our assignment discussion.
Okay, great.
Okay.
Thank you. Thanks for your time.